Alright, today we're going to review again with how to model solving a two-step equation, and then in our next lesson we're actually going to show you without the model and just the math process. So this is just getting our brains to kind of think about why, when we're solving with the math, how it makes sense with these pictures. So the first thing I want to show you is sometimes they're going to give you a picture on a test and they're not going to tell you what this represents. So if it helps you out, or sometimes they will ask you, what does this picture represent? Let's go ahead and look at that. So on the equation, on the left-hand side, this expression has 1, 2, 3 x's and a positive 1. And then on the right-hand side of the equation, we have 1, 2, 3, 4, 5, 6, 7 positives. Okay? So we're saying if we knew what x was, we would multiply by 3, then add 1 to get to 7. So there's only one true number that we could put here to make this equation balanced on both sides. So we want this value over here to be 7. So ultimately what we want to do is we want to get our x, our variable, by itself. So we need to first get rid of the constant, this positive 1. So the only way we can get rid of a positive 1 is with a negative 1. So negatives are usually shaded in just to kind of help us out, or unshaded, or we could have just written it like, you could have done this, or you could have drawn it like this. Either way means the same thing. So the ultimate goal is to get those x's by themselves, so we get rid of the constant first, that positive 1, and the only, that's our inverse operation, so we're going to add a negative 1 to each side. Then we're going to create zero pairs. A zero pair, remember, is when a positive and negative cancel out. So now we have 3 x's, if you think about it, not sharing 7, but what we have over here now is 6. So I'm going to move this down and say 3x equals 6, because that number has now changed. So now we want the x's by themselves. So 3 x's are sharing 6 positives. So what we want to think of is for every 1x, let's see, that's 3 groups. 3 divided by 3 is 1, and that's what we want. We want x by itself. So if I have 6 over here, and I need to put 6 positives into 3 equal groups, there we go. So we're saying that x is going to be equal to 2. And again, we're showing with the picture, but we can actually use substitution to see if we're right. So if I had 3x plus 1 is equal to 7 as my original equation, I'm going to take this number 2 and plug it in where we see x. So 3 groups of 2 plus 1 equals 7. Remember, when our coefficient is next to our variable, that means multiply. Your coefficient is the part that's working with the number. So it could be right next to it, or it could be underneath it to represent division. So order of operations, we multiply first. 3 groups of 2, or 3 times 2 is 6. Bring everything else down. 6 plus 1 is 7. And your equation is balanced. It's 7 on both sides. So we know that the only number that we could substitute in for here in this picture would be 2. Okay, so we're going to show you how to do this without the picture in the next lesson, but this really helps you to understand the process as well. So let's look at this next one. It says the model represents 2x plus 1 equals 7. And they even give you a key down here. So the circles, or the ovals, are x's. The positive box is a positive sign. And then the negative are our negative signs, our negative numbers, our integers. So we're not even solving. We're just thinking about the very first step. And this is what we call a process question. Sometimes that's all they want to know. What would you do? So again, you have to think about, ultimately, you want these x's by themselves, but actually just 1x to see what it's worth. So what is over here on the side with the x's that we want to get rid of? We want to get rid of that positive. So how do you get rid of 1 positive? You would draw 1 negative. So did I divide by 2 yet? No. Did I add a positive? No, because a positive wouldn't cancel out. So it's not these two. Did I multiply by 2? Nope. Remember, your ultimate goal is to get these x's by themselves. Yep, we added a negative to each side. So you're getting rid of that constant first, whatever's with those x's, so that way you're leading to get those x's by themselves. Now you're going to answer a few questions based on these pictures and also the process. Good luck.